Welcome all. Today in building services, we will get to know about the smart building technologies. So what is first of all our smart building and what are the technologies that can be incorporated to make a building as a smart one. So first of all, what is a smart buildings? So that is uses sensors, automation and the software. So which is to monitor and control the operation automatically. Then continuously senses the conditions. For example, temperature, occupancy, air quality, light and also the energy use. Then automates the key services. For example, lighting, HVAC systems, ventilation, water, air safety and also the security. Then optimizes in the real time, that is reduces the manual interventions and the human errors, and finally connects devices over a network so system can share the data and act together. So that is building operation which cover the lighting, HVAC, ventilation, water, energy, fire safety, security, elevators and parking. So these are the main services where the automation is used so that we can convert a building into a smart building. So first, definition of the smart building. That is, a smart building is a structure that integrates the automated processes to control the building operations in order to improve the comfort, safety, sustainability and the energy efficiency and also the operational efficiency. So why we need the smart buildings? Mainly in order to solve the energy problems. That is 35 to 40% of the total global energy is only consumed by the buildings. Then 30% of the total electricity was used by the buildings and 40% of the global carbon emissions is from the buildings. So in order to overcome these energy problems, we have to move on to the smart buildings. So what smart technologies reduce actually? There is electricity consumption, water wastage, carbon footprints and the operational cost. So electricity consumption, that is optimized lighting, HVAC and the equipment schedulings, and the water wastage, that is leak deductions and demand based supply. Then carbon footprints, efficient energy use and the renewable integrations, and operational cost, predictive maintenance and reduced manpower. Next, characteristics of the smart buildings. First one is the automation, connectivity, intelligence, adaptability and sustainability. Automation, that is system controlled without the human interventions. That is example, lights automatically on and off when it is unoccupied, it automatically off. When it is occupied, it automatically ons. That is what the automation in terms of light. Then about the connectivity, the devices communicate via the Wi-Fi, Ethernet, Zigbee, Bluetooth, LoRa, BACnet and the Modbus. Then intelligence, that is AI, artificial intelligence, analyzes the occupancy, temperature, weather and energy data to optimize the operations. Then about the adaptability. So operation changes with time, that is occupancy, weather and user preference. Next steps about the sustainability, reduces the waste use, electricity use and also the carbon emission. Next, evolution of the buildings, that is classified into four stages. Stage 1, it is the traditional one. Stage 2 is the automated building. Stage 3 is the smart building and stage 4 is the intelligent buildings. So in terms of stage 1, which is the traditional building, it is works based upon the manual operation, that is manual switches, manual locks and manual ventilation systems and all other manual operated things. In the stage 2, it is moved on to the automation, that is simple automations, that is automatic street lights, automatic pumps, timer, controlled lightings. In stage 3, that is the smart buildings, integrated systems, that is IoT sensors. By using the sensors, we will sense the data and we will monitor it and we will control it and we will communicate it. That is what the integrated systems, that is IoT sensors, remote monitorings, AI, artificial intelligence and cloud monitoring. It is the stage 3, that is smart buildings. In terms of stage 4, it is intelligent buildings, that is self-learning, predictive maintenance, for example digital twins, then machine learnings, autonomous decisions. So these comes under the stage 4, which is of the intelligent buildings. Next we will see about the components of the smart buildings. So there are 6 components of the smart buildings. First one is the sensor, controller, communication networks, BMS and actuators, and finally the user. So the data flows from the sensing and to the decision making, which is done by the controller, and for the communication by the communication networks and the central control, that is BMS, and for the physical action, that is done by the actuator, and the user, which is the occupant experience. We will see about the components. So first one is the sensor, that is we have the different real-time data collection sensors, that is a temperature sensor, humidity sensor and motion sensor. Temperature sensor measures the room temperature, example the thermostat controls, and humidity sensor measures the moisture used in the hospitals, labs and museums. Then motion sensor detects the movement for the automatic lights, doors and the security. So next is the smoke sensor, that is detects the smoke particles for the fire alarm systems, and CO2 sensor measures the indoor air quality, triggers fresh air ventilations, and light sensor measures the daylight intensity, dims artificial lights, and water leak sensor detects pipeline leakages, auto shuts of water supply. Next is about the controller, that is the second component, that is processing the sensor data. So it receives the sensor signals, makes decisions, and also use it to operate the equipments, that is PLC, programmable logic controllers, that is industrial grade automations, and microcontrollers, that is compact embedded chips for the localized control, and embedded processors run dedicated control softwares, and industrial controllers, that is handle large scale building systems. So these are the different controllers which will be used based upon the requirements. Next, we move on to the communication networks. That is, we have to the data has to be communicated. So it will be communicated by using these devices. That is Wi-Fi, Ethernet, BACnet on the Modbus, then KNX, Zigbee, LoRaWAN, and the Bluetooth. So Wi-Fi, it is a wireless local networks, and Ethernet is the wired high-speed backbones, and BACnet on the Modbus, that is building automation protocols, KNX, that is European automation standards, Zigbee the LoRaWAN, it is a low power wireless mesh, Bluetooth short range device pairing. Next is about the actuators, so which transforms the data into the physical action. So the actuator converts the controller's decision into the real physical change in the buildings. So electric motors and the servo motors drive mechanical movements, and valves and the motorized dampers regulate the flow of water and the air. Then relays switch electrical circuits on and off. The applications of mainly in the or for to open windows, close valves, switch lights, and control the HVACs. Next is about the building management system, which is known as the BMS. So it is the central monitoring, remote operation, fault detection, energy optimization, maintenance scheduling, and the alarm management. That is, it is the brain of the smart building. So BMS centrally monitors and controls every automated system in the building through one integrated platform. This is the BAS architecture, that is which is the data flow. So first one is the building devices generate the raw physical signals. Then the sensor captures the temperature, occupancy, air quality, and whatever necessary data, and the controllers process the signals. Then the communication networks transmit the data. Then BMS server aggregates and stores data centrally. Operator computer allows on-site monitoring and control. Then cloud platform enables the remote access and the analytics. And a mobile application gives occupants the real-time control. So it is an end-to-end loop. So every layer feeds the next from the single sensor reading to the facility manager's mobile dashboard. Next is about the advantages of the BMS. So that is energy saving, low maintenance, comfort improvements, easy monitoring, centralized control, and fault detections. So energy savings, that is optimized scheduling cuts wastage. Then the low maintenance, predictive alerts reduce the breakdowns, and comfort improvement, consistent temperature and the air quality. Then easy monitoring, single dashboard for all the systems. Then centralized control, one platform for every subsystems, then fault detection, early identifications of the failure. Next, we will know about what is the smart building systems. So first, in terms of HVAC automation, so 40 to 60% of total building energy is consumed by the HVAC. That is a main problem which we have discussed in the earlier slide. So the single largest target for the automation savings. So it works based upon the occupancy decreases in a zone, and the motion sensor detects the fewer people present, and the controller automatically reduces the cooling and the airflow. Then electricity consumption decreases in that zone. Next is about the lighting. The second problem, that is 20 to 30% of electricity is consumed by the lightings. So these components are that is LEDs, occupancy and daylight sensors, smart switches and the techniques are dimming, scheduling, motion and the remote control. So it works based upon this flow, that is sunlight enters the room through the windows. A light sensor measures the illumination levels, and controller compares the reading against the required LUX level, and the artificial lights dims or switches off automatically. Then the electricity is saved without affecting the comfort. Next is about the water and the vertical transport. So vertical transport is nothing but the example, or that is the lift and the elevators or the escalators. So smart water management and the smart elevators. In terms of smart water management, the smart meter tracks the consumption in the real time. So leak detection prevents the waste and the damage. Then rainwater and the tank level monitoring. Then water quality sensors ensures safety. So it is mainly used in the apartments, hospitals, airports and hotels. Next is about the smart elevator systems. So learn building traffic patterns, reduce passenger waiting times, save electricity via regenerative drives, and predict maintenance needs in the advance. So use destination control systems. Next is about the smart parking systems, that is the technology used as RFID tagging and ANPR, that is number plate recognition method, and the ultrasonic occupancy sensors in mobile application for the booking. So these benefits include reduced traffic congestion, less fuel wasted searching for the spots, then quick guided parkings and automatic entry and the exit billings. Then other one is for the structural health monitoring, that is sensor monitor the cracks, vibration, deflection, strain, settlements and corrosion in the bridges, tall buildings, dams and the industrial structures. Next is about the fire safety. So the smart fire protection, that is a response sequence. So the components include the smoke detectors, heat detectors, gas detectors, sprinklers, emergency lightnings, a fire alarm panel and the voice evacuation systems. So the workflow is the smoke or the heat is detected by the sensors, then fire alarm panel activates the alarm, then fire door close automatically to contain spread, then sprinklers start to suppress the fire, and the emergency light exit lights and the voice evacuation will be turned on, and the fire department is automatically informed. Next, in terms of security, the smart security systems. First one is the biometric access, face recognition, RFID card, smart locks, CCTV analytics, and the intrusion detection. In terms of biometric access, there is a fingerprint or is iris based entry controls. Then the face recognition, AI based identity verification at the entry. RFID cards, that is contactless access credentials. Then smart locks, remote controlled apps based lockings. Then CCTV analytics, AI driven video surveillance and alerts. Intrusion detection, automated perimeter branch alarms. So these are about the smart security systems. Thank you.